Hi everyone. Shift left is a buzzword that many of us in the testing world are familiar with. While some companies claim to use it, others swear by its effectiveness. But what exactly does shift left mean and how can we implement it successfully? In this video, we'll take a deep dive into the concept of shift left testing. We'll discuss its benefits, challenges, and best practices, as well as the mindset shift that's required to make it work in your software testing strategy. Let's start by defining what we mean by shift left. In software testing, it refers to the practice of moving certain testing activities earlier in the development process. The idea is to shift the focus from testing at the end of the process to testing earlier and more frequently throughout the development cycle. This approach requires a shift in mindset, as it aims to embed quality into the development process by catching and resolving issues earlier, before they become more difficult and expensive to fix. The term refers to the concept of shifting the focus of testing towards earlier stages of the development cycle. Early stages such as requirement gathering, design phase, and even code development. This concept has gained immense popularity in the recent years as it offers superior results in terms of cost and time compared to traditional methods. The idea behind shift left is to prevent bugs from being introduced in the first place. By analyzing the requirements from quality perspective and conducting tests earlier in the development cycle to detect potential problems before they are written into the code. It is a proactive approach that emphasizes quality and defect prevention instead of finding bugs only after the code is released into production. You can even look at it as a filter, as you eliminate more and more issues as the development process continues, but you're doing it in every stage and early. We have several other testing methodologies and practices that are widely used. How do they align with shift left? Let's look at a few. Waterfall model. In this methodology, testing was often performed at the end of the development cycle, as each stage was only performed after the previous ended, which meant that defects were discovered late in the process, making it more difficult and costly to fix them. For testers, waterfall model means they have zero impact on the requirements and the design. Knowledge gathering is limited, and allocated time for providing feedback is very limited. Shift left aims to de-emphasize traditional waterfall. Agile testing. Agile methodologies were designed to improve the software development process by breaking down the project into smaller iterations. Agile, in effect, eliminates the shortcomings of waterfall system. In Agile, testing was performed throughout the development cycle, but often not as early as in shift left testing, as it's not the emphasis here. Shift left can be used within an Agile development process, but it is not a replacement for Agile. Both approaches can be used together to achieve greater efficiency, collaboration, and quality in software development. You can say that shift left enhances Agile. Test-driven development, TDD, is a programming practice where developers write tests before they write the code. While this practice doesn't necessarily involve testing earlier in the development cycle, it does emphasize testing as an integral part of the development process. Shift left and TDD are not better or worse than one another, but rather they are complementary approaches that can be used together to achieve greater efficiency and quality in software development. TDD can be seen as a specific implementation of shift left testing, as it involves writing tests early in the development process to catch defects early on. But TDD focuses on the development stage only, while shift left overlooks the entire process. So shift left seeks to de-emphasize old waterfall development processes and to enhance others. We can see that development will always flow in the same direction. Shift left seeks to push it in the other direction in favor of testing. This push, in many ways, is achieved by automation. You can say that shift left favors automation. It favors continuous integration and continuous delivery, which enables faster development cycle. In shift left, the software is moved from a manual process that is out of sync with the development cycle to an automated process that is in sync with the development lifecycle and typically driven by automated software testing. Instead of relying on manual human effort to test and validate the code, which can be performed at any given time after the code is committed, the software is tested using automated methods, which can be performed immediately after the code is committed. For example, when a new code is pushed, it automatically triggers a set of automated tests. The new code cannot be committed unless all the tests are passed. This ensures that the tests are expected in a timely fashion alongside development. While code is being developed, potential issues are identified and addressed well before a crucial deadline and early in the process. The alternative, the not shift-left approach would be to push the code and wait for a manual intervention for executing the set of tests. By having the test run immediately, the development team can quickly identify any problems and reduce the feedback loop needed to get the development completed. This helps to reduce the number of production issues and decreases the time to market for the software. As a direct result, shift-left helps organizations reduce the development cost, increase agility, and deliver high-quality software. The advantages of adopting a shift-left approach are numerous. It reduces the overall cost of software development by decreasing the backlog of defects that need to be fixed in the production phase. We'll always have production issues, but a proper implementation of shift-left will reduce the amount drastically. It enables earlier identification of integration and functional issues, resulting in fewer issues during the end of the project. It allows tests to be conducted using real-time data at an earlier stage of the development process, allowing for a better and deeper understanding of the system. One of the key benefits of shift-left testing is that it helps to create a culture of quality throughout the organization. By involving everyone in the testing process, from developers to testers to business analysts, you can foster a shared responsibility for delivering high-quality software. This, in turn, leads to a greater focus on quality throughout the lifecycle, which can help reduce the overall number of defects in the final product. Testers, by nature of this method, are now part of the development process from its earlier stages. There is much more room for communication, exchange of ideas, and comments and collaborations. I see it as probably the main challenge a tester has. Create a quality culture throughout the organization. Make everyone involved. Shift-left can help you with achieving this. And at the end of the day, and probably most importantly, it improves the customer experience as the final product is tested in real-world environment before it is released. Let's work with an example that would help us understand the importance of shifting left. For this example, we'll use a banking app. We all know that you don't want to mess with your client's money, so every small detail and cent are important. The bug: two systems are using different decimal precision, which causes unwanted roundups. Using 2 decimal points precisions, a number such as 13.567 would be rounded down to 13.56, while using 4 decimal points precision, it would be rounded up to 13.5670. This can cause discrepancies in the data if the two systems are not aware of the different level of precisions being used. It is important to ensure that both systems understand each other's level of precision in order to ensure accuracy in the data. Such a bug in our system could cause clients to lose money and seriously harm the app's reputation. Let's demonstrate the potential cost in each step. Requirement gathering. If a bug is found at this stage, it is beneficial as it allows all members of the team to be on the same page when it comes to expectations and what the clients actually want. This can save time and money later on. It is usually free or very inexpensive to fix a bug at this stage because it requires little effort and hardly any work was probably done in terms of dev. The potential cost could be needing to freeze the development until we regather the requirements again, but it's negligent compared to finding the bug at later stages. Design. Problems found during this stage can be easily rectified if they are caught early. Finding a bug at this stage will cost significantly less than at later stages and can save a lot of time and money in the long run. Same here, we might need to go back to the requirements and amend our design. That is why it's important to perform design review and make sure testers are present. This is your place as a tester to ask questions, even the trivial ones. Development testing. Bugs found at this stage can be expensive to fix, depending on how deep the code is and how long the bug has gone undetected. The cost could grow if integration with other teams was required and we need to perform multiple dev cycles. However, it is still possible to rectify the issue at this stage. A good way to find bugs early at this stage is to write the test plan as early as possible, before coding had begun, and present them to the team. This step creates another discussion and brainstorming in addition to the design stage, which could help us discover hidden issues. Deployment. Bugs discovered after deployment can be the most costly and difficult to fix. Cost is affected by factors such as how many customers are using the new version, how long has it been in production, how many customers are using this specific flow. The worst cost is reputation. Once you lose your customers' trust, it can be very hard to re-establish it. I hope this example demonstrates, even a bit, how being present as early as possible can make a huge difference on the development process and the outcome. So, shift-left is great, I hope you agree. It has many benefits and we can save a lot of time and money. But what do we need to do to implement it? To help you adopt the shift-left approach, I'll share some general actions that you can take as a roadmap. Additionally, I'll provide some practical tips that you can apply independently and right away. From an organization's perspective, although the specific steps to implement shift left can vary depending on the project and organization, there are a few key steps that can be taken. It will require for everyone to be on board. This means that someone, potentially you, will need to advocate for this approach. 1. Define the scope and objectives of Shift Left initiative. Is it just in my team, the entire group, or even organization-wide? What is our current CI/CD state, and how does it align with my goals? Can I implement it on my own, or do I need DevOps involvement? Break down the big picture into smaller tasks, and use your colleagues for proper research. 2. Identify the key stakeholders, including developers, testers, business analysts, DevOps, etc. It would help you understand the scope better and resources required. Also, you'll probably need them on board. The more you communicate with them and explain your motivation better, the more likely you'll receive their help. 3. Implement metrics to track the effectiveness and ROI of the Shift Left initiative. Basically, what's in it for the organization? A good, simple, and effective way to demonstrate ROI here is to use real examples. Highlight cases where fixing a problem was costly, and demonstrate how Shift Left and automation could have saved a lot of time and money. The stakeholders must know that it is worth it. 4. Start integrating testing activities and automation in the development process. Mainly, testers are involved in every part of the process and implementation of CI processes that would have blocked any defect from being introduced into the system. Lastly, continuously assess and adjust the Shift Left approach to optimize its impact and value. The process should fit your organization's needs. Feel free to adjust, but maintain the principles. This fine-tuning is a long-term process. Always strive to receive feedback and improve. It's important to emphasize that the cost of implementing Shift Left testing may be higher upfront, which may be a bit alarming for the organization at first. For instance, implementing automation and CI, as we've seen earlier, but they can lead to significant cost saving in the long run. If implemented properly, any resources allocated to implementing Shift Left will be outweighed by the resources saved by preventing issues from occurring further down the line. Just consider the reduced rework, improvement in time to market, and customer satisfaction. The potential gain here is enormous. Now, these actions are for the long run. Is there anything I can do now? Without a doubt. Small steps can make a huge impact. Here are just a few. Be there all the way. Make sure you're there in every step of the development process. As a tester, you have a unique view and insights. They allow you to ask the right questions, raise the right concerns, and consider flows nobody else thought of. They need to be heard. You'll be amazed how many times the requirements of design are flawed or missing from quality perspective. Deliver early. Every tester writes test cases, but they only mean anything if they are shared with the team. Write your test cases, present them to the team, and ask for review and feedback. And here's the crucial part. Do it before development begins. Imagine the impact it makes on the development if the developer already knows in advance which test scenarios the code will meet. Your test could pass on the first take as we are all aligned on requirements and expectations. As for early delivery, in many cases, testing starts late as we must wait for the development to be ready for testing. And a lot of developers don't want to deliver new code for testing until they feel it's ready for testing, which is understandable. But we need to eliminate this idle, wasted time. Ask that the code will be delivered for testing as early as possible. There are two main ways to achieve it. 1. Work with the team to break assignments to smaller tasks. Depending on the assignment, sometimes it may even speed up the process when you consider all the potential tests and dev cycles required. 2. When possible, ask for stubs. For example, a developer is working on a new API which is quite complicated. It will take some time to develop. Ask the developer to deliver the API with no logic implemented, just a request and response with fake data. It will allow you to start examining the API and even start executing tests with minimal wait time. Early delivery was especially beneficial for me when I had to test multiple features. Instead of being a testing bottleneck, I was able to advance in my effort in smaller steps alongside the developers. Communicate. Take it as a general tip. Always communicate with your team. Ask for and provide feedback. Talk about the testing process, how you and your team can improve it. Both sides will need to adjust, but it would only happen if you talk openly. I want to encourage you. If anything doesn't seem right or doesn't make sense, speak up. It might be right after all. but it is always recommended to ask, even if something seems obvious. Consider how much time, money, and effort we could have saved if someone just asked one simple question, one that all thought had an obvious answer. What is the precision for the amounts we use in our system? Is it aligned throughout all of our system? Don't forget, testing is about mindset, quality mindset. Thank you for watching my video. I hope it was insightful and provided you with new and useful information. Please comment for feedback and feel free to ask questions. I'd love to continue the discussion. I hope you enjoyed Blueprints for Better Testing.